In this particular drainage district, it's called the Groesbeck Park Drain. It's a drainage district that is relatively new. We just created it maybe 10 years ago or 12 years ago, something like that. And the problem that we have here is that it is completely isolated from any outlet at all. And water used to collect here. It used to come down from the north, down the hill into this area that is a little bit of a swampy area, but it certainly isn't what you see today. And it used to collect and then go over into the Bancroft Park area through the Groesbeck Golf Course. And from there, it would go underground into a landfill, which is right over to the west of this area. That landfill is buried fly ash, and pollutants generated from the fly ash are generated into the groundwater table. The Board of Water and Light owned the ash pit, and its creation was the sand and gravel that made up of most of 127. When they were building 127, they borrowed the sand and gravel from this pit here, and it created a pollution problem. After they were done building it and extracting the sand, the Board of Water and Light bought the property for a place to deposit its fly ash from coal burning to produce electricity to run the turbines. And what that created was a major groundwater problem. There's one of the largest eskers that exists in the state of Michigan, runs from just north of here through Bancroft Park. Bancroft Park is the only undisturbed area of that esker, all the way to the city of Mason. It's about 22 miles long. And an esker is a glacial deposit of sand and gravel stratified by the glacier movement and cracks in the ice that allowed the melting surface of the glacier to run below and move the captured sand and gravel that were all hung up in the ice and deposit it in a snake-like figure along the ground. Because it's all gravel and sand, it's very easy for infiltration to take place. In the case of this watershed, the area to the north, the buildings that you see behind and Lake Lansing Road, would contribute its pollution load down through this area into a pond that's on the northern end of the golf course. It would go through Bancroft Park and make it through the sand and gravel deposit, the esker, and wind up adding to the pollution problem caused by the Board of Water and Light's ash pit that was formed here. These ponds are the first collection of water from the watershed, which is just shy of a square mile. And it comes down through here, completely polluted. That's almost, I would say it's about 90% impervious up there. And it comes down into these ponds, and these ponds take a bulk of the pollution away. But not all of it, but some of it. Probably about 60% of it, the pollution is extracted from these ponds. It goes under where we're standing. The two covers that we have here control the pipe that goes to the golf course. On the golf course side, it goes into the pond where, again, when it reaches a certain level, it goes down to one of the ponds in Groesbeck Park and then stops. It doesn't go any further. And then all of the excess water is then filtered back through an outlet pipe into this 36-inch pipe, and it makes its way all the way to the river from there. Now, we estimate that we're getting somewhere around 80% of the pollution out of the system, but the biggest benefit to this is that it's no longer polluting the groundwater. This water is the pollution in this water is no longer polluting the groundwater. I should say that twice, just so you understand. This is about groundwater protection, and it's not about managing the surface water. But in order to manage the surface water properly and have an outcome of eliminating the pollution entering into the river and or the ground, especially into the ground, we had to design this system to do that. And in these ponds up here, I have floating islands, which allow their root systems to go down about 2 or 3 feet into the bottom of the pond, which picks up pollutions as they go through and run through it, and the plants digest all that pollution. And I have all kinds of pollution elements in the golf course area that a lot of this water is taken out by the golf course to water the fairways and to water the greens and so on that it has on the golf course area. And that, combined with the evaporation rate of this water and a 36-inch pipe, I can manage the volume of water without polluting 1 bit of the ground. I think that's a major accomplishment. Now, the cost of this kind of pollution abatement and groundwater protection and stormwater building costs somewhere around $9 million. And the remodeling the golf course was part of the cost. Fixing up Bancroft Park added to the cost. But the $9 million spent was cheaper to do it this way than doing it any other way, any mechanical way of manipulating the water in such a way that it would pollute the river, 1, and it doesn't now, and 2, just managing the volume. We did it without a whole series of storage areas that typically are managed. We put more land on the tax rolls by doing this. The building that you see behind me, the medical building, is a product of clearing up that land for this particular drain and allowing that building to be built and pay taxes. It's incredible. And Bancroft Park, for example, never used to have many people in it at all. And today there are hundreds of people that use that park. It's just incredible. And these ponds to the north of me, the first deposition of these ponds, have a walkway all the way around it. And it's used all the time by the people in the buildings to the north for lunch hours. They come down here and eat lunch and walk around the ponds. It becomes a gathering place, a place to recognize. And we're getting ready to put up some signs in here that explain that this is more than just a park, more than just a place to walk the dog, more than just a place to relax and enjoy the scenery or enjoy the woods. But it's a whole urbanized stormwater system that abates groundwater pollution, abates surface water pollution, and manages the volume of water to the tune of about a 100-year event. Okay, what you see behind me now is the outlet to that water that's going into the northern part of the Groesbeck golf course in the city of Lansing. It's a municipal run golf course, and on the southern side of that golf course I have holding ponds for the toll gate drain, which handles about a 500-year event. And this pond to the south of me, behind me, and the ponds to the north can handle the equivalent of a 100-year storm. And that's without flooding one basement, without doing any problem at all. Now, what we had here before was a collection of all that impervious water came down here with no outlet, and most of the houses on David Street ran off of septic tanks. All of their septic tanks were flooded and they couldn't flush their toilets during a storm event. Today we have them all hooked up to grinder pumps, and we pump their raw sewage up the hill and onto Wood Street, where underneath Wood Street it meets with a sanitary sewer. And in order to make the drain work, I had to rebuild Bancroft Park, which we're going to go look at now. This pond on the golf course is part of our collection system, is where we store the water. You'll see a concrete oval cistern down here that collects the water and it divvies it out to the wetlands below, almost 25 feet below the elevation of this deck. Even further than that, I think it might be as high as 30 feet lower. And it's that path through this part of the esker that the polluted water used to travel to make its way to the groundwater. And by controlling the flow of this water to the wetlands below, I can store some water, but I also have the ability to manage the volume of water in this pond here. So I can, at any one point in time, it depends on the storm event, I can plug this one up and force the water out the 3-foot pipe on its way to the Grand River through Old Town. So by managing the water in this way, I always think of it in terms of how is the public going to interact with it. This Bancroft Park is one of the gems of the city of Lansing. It's full of wildflowers. It's got wildflowers that are on the brink of extinction in here, and we were real careful not to disturb them, or we probably will never tell people where they are so that they come in and dig them out. But we have total control over all of those. The easement that I have for drain management includes all of this woods. And I can come in here and manage the stormwater through several different outlet functions and manipulate the elevation in this pond as it relates to the 3-foot pond. It's a very complicated process, but my staff is pretty good at it now, and we can make sure that this water never hits the groundwater and pollutes our drinking water. This water is totally completely polluted, and when it's done processing it through these series of ponds that I've created, the pollution is easily dealt with and goes away, basically. And we wind up with a better system, both from the management perspective of volume and from a management perspective of quality. And it was very hard to achieve. It required several lawsuits and several years of planning and so on and so forth, and redesigning and so on. But we finally made it, and I would have to say that this is probably one of the more beautiful places within this urban city of Lansing to come and walk your dog or ride your bicycle, or just come in the winter to cross-country ski. It's beautiful. Between this and the Montgomery drain and the toll gate drain and many other drain utilities that I have created, you should have no problem finding a place to recreate. This pond is a perched wetland for all intent and purpose. It was excavated maybe 60 years ago or longer, and they pulled some gravel and sand out of this area. But when they pulled the sand and gravel out of here, they created this wetland, this perched wetland. And this perched wetland is about 30 to 40 feet lower than the pond on the golf course. The pond that we're going to look at in a minute is about 40 feet lower than this pond. That's an accumulation of 80 plus feet that the water used to come in from the watershed through this area, make it around this path right down here, which is an old dried up bed that used to flow this water, and it flowed underneath the road, and it went down into that sand pit, which was excavated to make the concrete for the Eckert power plant. And they pulled the sand out of that because it was cheap, and they made the concrete to produce the Eckert power plant here in Lansing. Now, they left that hole in the ground, but on the other side of the northern side of that hole is the landfill that the Board of Water and Light spent 40 years filling up with pollutants. And it's that landfill that this water made a beeline underneath the ground, through the hill and through the ground, picked up the pollution and moved it 2.5 miles to the southwest. It was a major problem. And this surface water drainage project solved that problem. We no longer contribute a drop of water to that migration of pollution. The only water that goes in the ground through this esker system here is that which it rains on or snows on. No, it doesn't collect water from any street. It doesn't come from any place else. It used to come from that whole square mile to the north. Used to come through here and contribute a major drinking water problem and a groundwater pollution problem that we solved by building this project. So this is totally controlled in terms of its volume, and this particular location is where the water stops. It does not go into the ground any further. It does not go into the ground at all. Not one drop of it goes in the ground. So we completely solved the groundwater problem that we were suffering from with this project. Okay, what you're looking at behind me is the pit that was dug out back in the 1950s to build the Eckhart power plant. And from the pit, they took the sand and gravel and made concrete, and that's all part of the building of the Eckhart power plant. But this ground, the ground level on the bottom of this pond is 40 feet lower than the previous pond that we looked at, which is about 30 to 40 feet deeper than the first pond on the golf course, where the elevation of the stormwater comes into the system. It's through this pond that the esker, forced into the water by the weight of the water, forced into the ground, all of that water that goes down about 200 and some odd feet down to our drinking water level, the Saginaw Aquifer. This esker and the Saginaw Aquifer meet each other. The Saginaw Aquifer is mainly sandstone, but this had scraped off the top of that sandstone and allowed a layer of gravel and sand to be placed when the glacier melted on top of that became the Saginaw Aquifer, which is about 90% of southern Michigan drinks from that aquifer. So this point of pollution produced a plume, again, about 2.5 miles long to the southwest. And that plume is now being back pumped and cleaned through a series of pumps which are across Lake Lansing Road. They're operating as we speak to back flush that water. We are putting water in downstream of that plume and forcing the water to the north where we can capture it and clean it and dispose of the pollution properly. And we hope to clean up the aquifer at that point, but it's going to be 30 to 40 years or 50 years before the aquifer is cleaned. But at least we aren't putting any more pollution in the aquifer via this stormwater. When they were building 127, they borrowed the sand and gravel from this pit here, and it created a problem. After they were done building it and extracting the sand, the Board of Water and Light bought the property for a place to deposit its fly ash from coal burning to produce electricity to run the turbines. And what that created was a major groundwater problem. There's one of the largest eskers that exists in the state of Michigan runs from